Hi, okay, welcome to session 5. We're going to be doing some ratio today. Before then, obviously, we have our lovely recap. So I'd like you to hit pause and press play when you're ready. Please don't treat this as a test. I know I've said it before, but it's really, really important. If you do need to look and check out a method, then do that. That action of you going and having a look is going to help with that recall anyway. All right. All right. So have a go and press play when you're ready. Okay. So there's the answers. I suggest you hit pause and then you can literally go through all the workings are there. So you can check in and see whether or not, if something's gone wrong, where it might have gone wrong, and then hit play when you're ready. Okay, so the only thing for me to really state, and it's the obvious, is all four fractions are now there, every single operation. So it is a real test now of linking the right method to that right operation. So add, subtract as your bus shelter, etc., etc. And again, just be really mindful of your Chinese method. Just count those decimals back in and don't try and include them when you're actually doing your working out. Okay, so hopefully that went well. As I said, we are going to be looking at ratio, and we're going to be doing something called the column method. Now, the column method isn't widely used in textbooks or classrooms, so this might feel very new to you. I use it, obviously, and I use it because it is a fabulous method that once, like all methods, once it clicks into place, it's just very, very easy to use. And it works. It just works no matter the question. Okay. But with ratio, because it's a bit like percentages, because the questions can vary so much, it feels like a new ratio question every time you do one. So if you're relying on recognizing a question to answer in the exam, then you're not relying on a deeper understanding of the method. You're just trying to match, oh, I know how to do questions like that. We want to avoid that and be thinking, right, I know my methods for ratio. So we've got to develop that real secure, deeper understanding of the methods. And obviously I'm introducing it quite early in the course so that we get that repetition and we really start to see how this works and apply it to things. So we're going to start off with just simplifying a ratio. So we're literally starting at the basics and we're going to build our way through. All right. So a really one marker basic question, it's grade 1, it's not grade 3, but we want everything we need to know to get to grade 3. So we're building from the foundation level. Could be something where I give you the ratio 10 to 12 and I ask you just to cancel it, to simplify it. Ratio works in the same way as a fraction. So in a fraction, if I'm cancelling a fraction, whatever I do to the top, I do to the bottom. With a ratio, I keep the sides balanced. So I look at these, I consider which times table they both come in. They're even, and I always like just halving when I spot that, and then checking again. So I'm going to divide by 2, and I'm going to do that both sides. That's going to give me 5 to 6. And then I'd be looking at that and thinking, right, can I go again? There isn't a times table that the 5 and 6 both come in, except for 1, of course, but dividing by 1 won't change the numbers. It won't cancel and make them smaller. So there's no point in doing that. So I've stopped. That is my simplified version. Okay, so have a go at this question for me. So just pause and press play when you're ready. Okay, so I'm thinking, which times table do both these numbers come in? And it's 5. I can't half because that's an odd number. So I've got to think a bit harder to find a times table. So I'm going to divide both sides by 5. And then that's going to give me 4, and 5 divided by 5 is 1. And that's the answer to that one, simplified. Let's do another one. Let's do 18.12. And please press play when you're ready. Okay, so I can see they're even. So I'm just going to take the easy option and divide by 2. That's going to give me 9 and 6. And then I've got to think about this. Have I finished or can I go again? Quite often when I'm halving and dividing by 2, it will go again, all right? And this one does. So 9 and 6, they are in the 3 times table, which means that I am going to divide by 3 now on both sides. And that will give me 3.2. And that is as low as it will go. And some of you may have spotted that 18 and 12 would divide by 6. So you divide by 6, 6's into 18 go 3, 6's into 12 go 2. You get the same answer, you just get there quicker. You get there quicker because you divided by a bigger times table. But you do what you see, just don't stop on the very first one in case it will go again, okay? So these ratio questions, this style of simplification, I am working in columns, yeah? Everything to do with the 18, I've got in this column, and everything to do with the 12, I've got in this column. So where I've written ratio within the columns, that's what I mean by that title. This type of ratio question I am keeping within the columns I've naturally been given, okay? Okay, so we're going to look at something that you might see on an exam question, okay? So it could be write the ratio 5.8 as 1.n. Okay. So what I want you to do is I want you to hit pause. I want you to think about what we've already done. And could you apply that to this? This question feels mean and really hard, but it uses the knowledge that we've already got. So would you be able to use that before I even show you? So hit pause and press play when you are ready. So this is what you need to do, okay? You take the ratio they've given you, you put it into the columns. I can't stress enough how important it is to stay in those columns, okay? And this side here has 2 pieces of information, and this side only has the 1 and this kind of missing number that they want me to find. To get from 5 to 1, I would need to divide by 5. And of course, whatever I do to one side, I do to the other. So I'm going to do 8 divided by 5. And I'm going to just stick this in the calculator. All right. S to D if you're on that style. And now I've got 1 this side. My n is 1.6. They might word it in a way that says work out n. And again, we kind of go into a bit of a panic because it feels like algebra. But that n is just like saying there's a number that I don't know what it is yet. So I'm just going to stick the n in. I could have just as easily have gone, I've got 5 to 8. That's going to 1. What's going to go there? Could have left it blank. And remember, whatever we do to one side, we do to the other, and that would be how I worked it out. Okay, so that one does feel a little bit different. Let's try it again. Now you've seen it. I mean, if you got it right, really impressive, actually. But let's try another one. Let's say we've been given the ratio 6 to 4, and we're going to write that one in this form. All right. Press play when you're ready. Okay, so I've got 6.4. n.1. So this is the side that tells me what to do because it's got all the numbers in it. So to get from 4 to 1, I need to divide by 4. I'm going to do 6 divided by 4. And again, you can stick that in your calculator. and you will work out that n has to equal 1.5 or 3/2. You will put it in whatever form you're asked to. If your calculator gives you 3/2 and it doesn't say anything about it has to be a decimal, then you would still get the mark by writing that down. All right, let's just do one more like that so that you've seen it at least a couple of times before we move on. Let's say this time we've been given 2.5 and we're going to write that in the ratio of 1 to n. Okay, so press play when you're ready. So let's put the 1 and the n under. Here we're dividing by 2. So here we're dividing by 2. And when we work that out, we get 2.5. Okay, so when we do those kind of recap questions, you're going to see things like this now appearing on them. And there's quite a lot that we're going to get done today. Okay, let's have a look at how fractions and ratios are linked. So we know how to simplify a ratio. We stay within the columns and we divide down, balancing either side to make the numbers smaller. I hope you noticed that we stayed in integers until we came up with that letter n, and then if a decimal came up, it came up. All right. So fractions, how are they linked? So let's draw, let's just sketch something out a second. It won't be beautiful, but it'll do the job. 1, 2, 3, 4, 5. We're going to pretend they're all equal. And I'm going to shade a couple of them in. And if I now said to you, okay, give me the fraction that's shaded, you would tell me, I hope, 2/5. 2 out of the 5 squares have been shaded. If I change the question to give me the fraction that are unshaded, you would tell me that 3 to 5 are unshaded. Together, these add up to a whole. They add up to 1. They're the complement of each other. Now, if we were to forget the actual fractions and we were just looking at this picture now, and I just said, write the ratio of red to, let's say, white, write the ratio of red to white or shaded to unshaded, you would write down 2 to 3. Now look at the fraction, look at the ratio, look at the similarities. The ratio is 2 to 3. The numerators are 2 and 3. And that is what a ratio is. The ratio links to the numerators of a fraction. So if I was to give you the ratio 7.9, the fractions, bearing in mind that I know that they must be the numerators, okay, have a denominator of the 2 added together. You can see that here. 2 plus 3 is 5. 7 plus 9 is 16. And that's all I need to do to get the denominators. And they're complements of each other. They would add up to the whole. They would add up to 1. Okay. So fractions and ratios are intrinsically linked like that. Let's just do one more. Let's do 3.5. Okay. So what are the fractions that relate to that ratio? And the answer is 3/8 and 5/8. What if I was to do it the other way round? What if I was to say, what is the ratio linked to that fraction? You've got one fraction given to you, and you've got to come up with the full ratio. Have a think, pause, have a think, do what is coming to you, and then see whether or not it's right by hitting play. Okay, I know that the denominators will be the same, and I know I need to add to make the denominator. So if I've got 2 here, I'd need 1 there. So the ratio is 2 to 1. If you got that right, really, really well done. Okay, let's do one more like that. I'm going to give you the ratio. What shall I give you? 4/9. Sorry, ratio. I'm giving you the fraction 4/9. You're going to write me the ratio that would fit with that fraction. Okay, I know it's going to be 9. I know it's got to add up to 9, so that's got to be 5. So those are the two fractions. So my ratio is 4/5. And again, this is the type of question that can come up quite early. It's around sort of grade 2 thinking, where they will give you either a fraction and ask for a ratio, or they'll give you the ratio and ask for a fraction. And this is where we will see it coming up in our recaps to just to build that knowledge and have that coming back a bit more fluently. Okay, so Sally and Bob. I'm going to write this down so that we can see it. So Sally and Bob share some money in the ratio 3/7. Okay. What fraction does Bob get? So that is the type of thing you could expect to see in an exam, where the question comes in this kind of worded story and you need to pick out that key information. Okay. So have a go. You know, the worst that can happen is it goes wrong. That doesn't matter at all. So hit that pause button and hit play when you think you've got an answer. Okay, so I am going to do, I'm going to pull the information. So I've got Sally and Bob. Sally comes first in the story and then it's Bob. So it's Sally to Bob. And I always label. If there's a story that enables labeling, I label. Okay, if there isn't, there's not a lot I can do. I can't invent them. But if they're there, I would get them labeled in, get it so that it's written in our mathematical way rather than in English sentences. Okay, we work as efficiently as we can, and we don't need all the information in the words. I need to know it's Sally and Bob. I've done S to B. I need to know the ratio is 3/7. Okay, I'm working in my columns. Yeah, so underneath it goes. It then says, what fraction does Bob get? So actually, the only thing I'm really concerned with is that bit there. Okay. So I know the fractions will have those numerators. Added together, they are 10. I'm only interested in this side, in what Bob gets. So the answer is 7/10. Okay, the answer is 7/10. Okay, hopefully that went well. All right, let's change the question. Sally and Bob are going to share some money in the ratio 3/7. We'll keep that up to save me writing right from the get-go again. And this time I'm changing the question. I'm going to say, if Sally gets £35, how much do they share? Okay. So if Sally gets £35, how much do they share? Right. So again, pause, have a think and a go, and press play when you're ready. Okay, so I've got my label of Sally to Bob. That's the important thing there. The ratio 3/7, so same setup as last time. Now, if Sally gets 35, in Sally's column, we can write down what she gets. She gets 35. Okay. So how much do they share? Well, the first thing I need to do is I need to work out what Bob gets. So I'm going to be multiplying this side by something that's going to take 3 to equal 35. Now, if it was 36, it would be 3 times 12, easy peasy, done, but it's not. So what do I do when the numbers aren't working quite so nicely for me? Okay, this is what I do. Grab my calculator. So when the numbers don't work very nicely, I can almost guarantee you are going to be on either paper 2 or paper 3 with a calculator to hand. Okay, now I know 3 times something is going to equal 35. Now, in order to find that something, I'm going to do the opposite and do 35 divided by 3. Okay, so let's do that bit working out over there. So 35 divided by 3 is equal to, and if I S to D that, I get 11.666, and on and on and on it goes. Now I mustn't round and I mustn't change the number. So if I'm timesing this side by 11.6 and on it goes, I must times this side by 11.6 and on it goes. So don't know if you can see that. Can you see my 11.66? I am not touching that. That is going to stay literally on my screen. I'm not going to hit the AC and clear the screen because I want to use this in my calculation. So I'm just going to leave it there and then I'm just going to hit times 7. So I'm timesing by 7. Okay. And when I S to D that, I get quite a nasty looking piece of maths. Okay. I get 81.666 and on it goes. Okay. But that's what Bob gets. Now it is money. So I do now want to think about rounding this so that it looks like money. Money is always 2 decimal places. So we're going to cut here. Is 6 5 or more? Yes, it is, which means I'm going to add 1 to this side. So I have got, let's just pull that up a little bit. I've now got 81.67 for Bob. And I've got 35 for Sally. The question was, how much do they share? So now I need to add these two. And remember, you must show all your working out when you are doing your maths. Everything could be worth a mark. You never know what you're dropping if you don't write things out. So I'm just going to add that 35. And they shared a total of £116.67. Okay. Now, I am going to keep a lot of what we do fairly straightforward, so things won't get too complicated too quickly. But obviously, by the end of the course, we want to be able to do any numbers they give us. Okay, so really, the main thing that I wanted you to get from this is when things don't go exactly, okay, I can't see easily what to times by, then I do the opposite here. That was the main point of that example, not for the numbers to get silly and complicated, but more to show you how to deal with it when you can't see what the times table is. Okay. I've also got another thing that we'll be learning that simplifies that even further for us. But for now, that's good enough. Okay, let's keep going. We've got a couple more typed up examples to help us now practice this. So I'll just clean that off just so we've got a fairly clear, and we want to go as far as we can without showing the next question. So Penny and Sue share some money in the ratio of 5 to 2. If Sue has £20, how much does Penny have? All right, pause and press play when you're ready to see how you've got on. Okay, so I've got Penny and Sue as my label. I've got 5 to 2 as my ratio. Sue has £20. I've really got to read carefully. So in Sue's column, I've got to put the 20. How much does Penny have? Well, that's the job. That's what we've got to work out. How do I get from 2 to 20? I times by 10, do the same this side, and we've got 50. So Penny has £50. Okay. Hopefully you went well on that. I told you I wasn't going to go too mad with the numbers to start off with. I think I was very kind. Okay, so there's your next one. I shall clean the, there we go, clean that bit off. Right. Apples are shared between boys and girls in a ratio of 3 to 4. If there are 9 boys, how many students are there in the class? Hit pause and press play when you're ready. Okay. Now this is kind of a typical exam question where you've been given a story and there's certain things within the story that they're not even relevant. So you read apples and that has absolutely nothing to do with the method and the important information that I've got to pull. It's just a part of the story. I could have said bananas or apples really isn't key. So as I'm reading through this, I'm trying to find the things that are key. I've got to work out how many students there are in the class. So this question is all about the students. So it's all about the boys and the girls. It's not about the apples at all. So I've got boys to girls, 3 to 4. There are 9 boys. So I can put 9 in the boys column. And then I can go from there. Timesing by 3 gets me to 9. Do the same. And I've got 12. Go back to the question. How many students are there in the class? So it's not how many girls. It's not just this missing number, but how many in the class altogether. Well, there are 9 boys plus 12 girls. So there are 21 students in the class. And if you got that right, really, really well done. Okay, so that is, we're at the end of the page. That is your next question. Dominic, Rachel, and Jasmine share sweets in the ratio of 4 to 7 to 2. If Rachel has 28 sweets, how many sweets are left over from a box of 100? Okay, so pause and hit play when you're ready to see how you've got on. Okay, so we've got Dominic and Rachel and Jasmine, 4, 7, 2. We are told that Rachel has 28 sweets. So in Rachel's column, we can put 28. And then we've got to think about how we get from 7 to 28. We times by 4, which means we're going to times everything by 4. So 4 fours are 16 and 2 fours are 8. So that's how many sweets they all get. So we need to know that total. So I've got 28 plus 16 plus 8. So 8 and 8 is 16. Add another 6, 22, and we've got 52. Okay. 100 minus 52 is 48. And that is how many sweets are left over. So if you got that right, well done. So that's when your question, when you read that question carefully, you realize that everything fits within its column and we just work through with what we've got. Okay. But we do get questions, and we're going to do them on this side. We do get questions where they don't fit in the column. So that's when I call it the invisible column. It's like it's not there until I make it appear. So let's give you just a really simple example of this. So I might say to you, right, share 96 in the ratio 5 to 3. Now there's no labeling, there's no story, there's not Bob or a Sally, and there's not a boy or a girl or whatever the label might be. So I can't do any labeling, but it is 5 to 3. Okay. I'm sharing 96 in to that ratio. So it doesn't belong in either of the columns. The 96 doesn't live here or here because the 96 is being shared between them. So where am I going to put the 96? I'm going to put it in an invisible column. So I draw a line here. Now that line doesn't do very much, if I'm honest, except it helps me remember the invisible column. So when I'm reading a ratio question and I've just got that and I think I don't have anywhere to put the number I've got in the question, then I drop a line in, I just go boom, I'm going this side of the line. I don't want it under these two, so I'm separating it away and I'm going to do my thinking on this side of the line. That's kind of what's happening. So if I'm sharing this total of 96, I could label this side total. Okay. Now, before I write my 96, I'm actually going to put the total of my ratio in. The total of my ratio is 8. The total, however, in my question is completely different. It's 96. So I've now got to think, what do I times 8 by to get to 96? So at this stage, I'm doing the exact same thing that I was doing previously. So nothing really massively has changed, apart from the fact that it didn't fit in my columns. So I've created an invisible column, which I can now see. So what do I times 8 by to make 96? All right. If you don't know the answer to that, then you are going to have to go away, work it out, use your calculator or whatever. Okay, this one works beautifully and quickly in my bus shelter. How many 8s go into 9? 1, with 1 left over. How many 8s in 16? 2. So I'm timesing by 12. So I'm timesing everything by 12. I've got 60, 3 12s are 36, and that's it shared. And this here should add to my total. That's a check that I could do to make sure I did all my maths correctly. Okay, let's do another one for you guys to have a go at. And please do pause and give this a really good go. In fact, I'll write it a little bit more like an exam question. Let's say we've got Peter and Jane share £84 in the ratio 5 to 2. How much does each of them get? All right, so that's the same question that I've just demonstrated, but in a wordy version, which is more likely to appear on your exam. Okay, pick out the key information and go for it. So hit your pause and press play when you're ready. Okay, so for this one, I know that Peter and Jane are in the story, so I've got some labeling and I'm going to use that. I always use if it's there. Then I've got my 5 to 2. We are sharing a total of 84. Peter doesn't get 84 and Jane doesn't get 84. So it doesn't belong in their columns. So boom, that tells me to make my own. So I separate it down and I want to share a total amount of money. The total of this ratio is 7. That's my first step. I must remember to do that. And then I've got 84. How do I get from 7 to 84? I times by 12. 5 12s are 60 and 12 2s are 24. They have to add up to my total, which they do. So I can be fairly confident that I've done that right. So if that's gone well, happy days. All right, let's do a different one. Let's do a different one. So we're going to say Marvin and Jay share some money in the ratio 3 to 8. Jay gets £25 more than Marvin. Lucky Jay. How much do they share. Okay, so yeah, why not have a play with that? Have a think, do whatever feels right, and then hit play and we'll see how you got on with it. Okay, so Marvin and Jay share some money. I don't have a total amount anymore. They've not included it in this question. They do give me the ratio, so I'll get that done first. So I've got Marvin to Jay with 3 to 8. It then says Jay gets £25 more than Marvin. And the key thing here is this, actually, the more than. If Jay gets 25, then 25 can go in Jay's column. But he doesn't get 25. He gets £25 more than Marvin. And that detail in the question totally changes the approach that you might take. So if you put the 25 here, I totally understand why, because it sounds very much like Jay, that the 25 would go into Jay's column because it's that they're so closely linked here. But this more than means that he doesn't get 25, he gets 25 more. So it's an invisible column question. But this time I'm going to label it more. And I'm going to look at that ratio and work out how much more he gets when it's just a 3 to 8 ratio. Okay, he gets 5 more. So if Marvin's got £3 and Jay gets £8, Jay has £5 more at this stage. He gets a total of 25 more. So now that goes in and I carry on as normal. I've got to times by 5 that side to make that true. So I'm going to times by 5 this side, giving me 15 and 40. The question is, how much do they share? So that's 15 plus 40, which is £55. Okay. Let's do another one. I'm just thinking I might adapt this question so you don't have to wait for me to write a million things out. Let's change the ratio. So let's say Marvin and Jay share some money in the ratio of 5